So this presentation is on measures of center. It's about deciding which measure of center to use. We have two different measures. We have the mean and the median that can be used with quantitative data, where the variable has values that are numbers. The difference between the mean and the median is that with the mean you just add up all the data and divide by how many there are, and so all the data are treated equally. It's a measure of center that is vulnerable to distortion if you happen to have one or two really extreme x values in your sample. And the median, on the other hand, does not have this vulnerability. You sort all the data in order, and you find the value right in the middle so that half of the individuals are above and half are below. And so this tends to suppress the effects of the extreme outliers out on the end of the distribution. So if you have a story, you can decide which measure of center is more appropriate or meaningful based on whether or not the extreme values should count as much as the more typical values. So if you're looking for a typical measure of center, use the median. And if you want all values to weigh equally, use the mean. Now sometimes you don't have a story, and in this case you can decide which measure of center to use based on the shape of the distribution. If the distribution has a bell shape, or we say the technical term is roughly normal, then we use the mean, and otherwise use the median. So let's compare these two stories. In one story, an athlete does the long jump 4 times, and we want to know how far does she typically jump. Well, that word typically gives it away. Maybe she jumped real short one time, but we wouldn't want that to count so much. We want to find just the value in the middle, where half the time she jumps more and half the time she jumps less. Whereas in the other story, a student takes 4 tests on different parts of the course material. And of all the material, what percent has the student demonstrated mastery of? Well, it's 4 different parts of material. It's not doing the same thing over and over. And you don't want to count one of them less just because it was not typical of the other parts of the material. You want all the parts of the material to count equally. So that's an example where the mean would be more appropriate. So let's continue with those two stories. Here's a table of data for the athlete's long jump results. So 18 feet, 17 feet, 15 feet, and then there's this one time, it's like the great Jackie Joyner-Kersee in the Olympics some years ago, that she had this one long jump where she tripped over that, that bar that you step on as you leap. She tripped, and so she had this one jump that was really short. Well, if you want to find out how long does she typically jump, you want to go right halfway between these 2 numbers in the middle. You get the median of the 4 numbers, halfway, you've sorted them out in order, and you go halfway between the 2 in the middle. And so you get 16.0 feet. We'll talk more about how many digits to report, but you report 1 digit more than the original data had to allow for going halfway in between. You could have had sometimes you might get, like a 7.5 going halfway in between. So that's the median. But then in this other example with the students' test scores, it's the same kind of situation, going along real good, 95, 92, 85. And then one time maybe the person was real busy, didn't get any sleep the night before, and so one of the scores was much lower. But you're trying to show, well, you've demonstrated mastery over what part of the material. So you add them all up and divide by 4. That's the mean, and you still report that one extra digit. That's it.